The overall goal of this procedure is to observe the anxiety experienced when mice are confronted with a novel food in a novel place. First, select a highly palatable food. Next, select the novel environment in which the animal will experience the food. Once prepared, introduce the animal and record behavioral parameters. Ultimately, results can be obtained that show changes in anxiety level through changes in eating latency.
Reading the hyponeophagia literature, I found that people often used very large arenas in which to place the food to provoke anxiety. But you can provoke anxiety with a very much smaller test arena. The result is that you don't get your hyponeophagia latency data contaminated by a lot of exploratory activity. Also, if the test compound or the lesion that you're testing diminishes motor activity, then that would be also a confound which would be much more pronounced with a large arena. But the small test arena will ensure that the mouse, even if it is very slow to move, does find the food fairly quickly. The whole idea of these tests is so that the mouse goes into the test apparatus and finds the food virtually instantly, and then you get a pure hyponeophagia latency datum.
The evening before testing, remove all food from the home cage except for 1 gram of chow per mouse. Break the pieces apart to be sure that group-housed animals eat equal shares. Next, choose the type of hyponeophagia test apparatus to be used. 4 types were developed with slight differences. It is important that dry bait be distributed evenly over the apparatus floor to reduce the need for exploration. In this example, liquid bait is contained within a food well. Baits of extreme palatability encourage the tasting of novel food and only require mild food deprivation. Seen here are examples of palatable foods that can be used as bait. To set up the test apparatus, glue a lead weight onto the base of a translucent plastic jug, about 15 centimeters in diameter, with a spout protruding a further 2 centimeters. Overturn the jug onto a white plastic base so that the spout covers a food well. Since odor may play a significant role in this test, allow non-experimental mice to explore the apparatus before testing starts. Next, align a row of small cages. Place 1 mouse into each cage about 5 minutes before testing and return them to the same cage after each trial. Fill the food well with full cream sweetened condensed milk, diluted 50-50 with water to serve as the bait. To begin the test, place a mouse onto the platform facing away from the well. Lower the jug gently into position, taking care not to trap the tail. Measure the latency to eat. This is defined as eating or drinking continuously for 2 to 3 seconds. Count any fecal boli and note any urination. Remove the animal after 2 minutes. If a mouse has not drunk by then, return it to its cage and retest it around 3 minutes later. Most animals drink within 3 trials. Before the next trial, clean the food well and the plastic base with a moist cloth, followed by a dry cloth, and refill the food well. Hippocampal lesions produce a strong decrease in hyponeophagia in mice. The latency figures in hyponeophagia testing are typically highly variable. The histogram shows data from 3 successive hyponeophagia tests in a single cohort of mice.
Following this procedure, the animals can be tested in different anxiety tests, such as the light dark box or the plus maze. However, we now know that anxiety is manifest in a number of different forms, and food-related anxiety may not necessarily be the same as anxiety as measured in the light dark box or the plus maze, for example. So we should always test any treatment that we're administering to the mice in all 3 anxiety tests, or as many as we can, in order to ensure that when the compound goes to the clinic, it's more likely to act as an anxiolytic in humans.